Variable acceleration worked examples part 2. So we're given displacement, we're looking for velocity. To get from displacement to velocity we need to differentiate. So differentiating, we have this, and then to get acceleration we differentiate once more. Part 2, when the particle returns to O, the displacement is 0, so we need to solve this. Factorizing, and this is the value we're looking for. Initially the particle was at 0, so that was when t equals 0, we already know this. This is the solution. When the particle reaches A, it comes to a stop, it changes direction, then goes back towards O, so at A its velocity is 0. So the velocity is 0, factorize and solve, and this is the value we're looking for. The maximum speed is when dv by dt is equal to 0, a stationary point on a velocity time graph. So dv by dt, or acceleration, is given by this. We make it equal to 0, and then we solve this equation. So t equals 1 second, but that's not the maximum speed, that's the time at which it occurs. Then use the velocity formula, so we have 2 meters per second when t is equal to 1. Example 6, we have acceleration and we want the maximum velocity. The maximum velocity is given by the velocity formula, so we have to get to velocity we need to integrate. Integrating, we have a constant of integration. Initially the velocity is 0, substitute in t equals 0, v equals 0, so c is equal to 0. So now we need a value of t to substitute into this to work out the maximum velocity. So maximum velocity occurs when dv by dt is equal to 0. So dv by dt is the same as acceleration, so 6 minus 2t equals 0. So t equals 3 seconds. Now we substitute t equals 3 seconds into the velocity formula to get 9 meters per second. Part 2, the velocity after 4 seconds, t equals 4, 8 meters per second. The distance travelled means we go from velocity to the distance travelled, we have to integrate. So we integrate the velocity formula, we work out the constant of integration using these initial conditions, so the distance travelled is 80 over 3 meters exactly. Example 7, a constant velocity for 10 meters per second. So after 3 seconds the velocity is still 10 meters per second, so we can put 10 here. After 3 seconds t equals 3. Solve to work out c. Part 2, an expression for s in terms of t. S is equal to 10t. This is for the initial part of the journey where we have constant velocity. For part B it will be different. For part B we have variable acceleration, so we are here to work out our formula. For S we need to integrate, so integrating, we have a constant of integration. The initial conditions are when t equals 3, S is equal to 30 meters. Substituting the values in, so we have c. Substituting that value back in here, we have the formula and this is for displacement for t greater than 3. The total distance travelled is a combination of what happens in the first 3 seconds and then what happens in the next 3 seconds. So in the first 3 seconds, using this formula, 30 meters. In the following 3 seconds, using this formula, so at t equals 3, the formula is giving us 30 meters. At t equals 6, it gives 105. The difference between these two is 75. And then you add the initial one in the first 3 seconds to this value in the following 3 seconds, 105 meters. Example 8. There is constant acceleration, which means we can use Subat formulae for the initial part. So v equals u plus at. So the velocity when it starts braking, 50 meters per second. In part 2, it says deceleration of 4t meters per second squared, which means the acceleration will be negative. So we need minus 40. A for acceleration is minus 40. We're looking for velocity, so we're here. To get to velocity, we need to integrate. So we're integrating. Constant of integration. Initially, v equals 50 meters per second. Substitute the values in, work out the value of the constant. So we have v is equal to minus 2t squared plus 250. The time, the total time for which the car is moving, we have a formula for velocity. So v equals 0 when the car comes to a stop. Solve 11.2 seconds. The actual velocity time graph, you've not been asked to sketch that, but it looks like this. So we have this initial constant acceleration and then a sudden non-constant deceleration. And this expression here, this actually gives an N-shaped graph similar to this, and this is one of the roots, and the other root would be down here, which would be minus 11.2 seconds there, which is a nonsense. But the total time for the journey, right there, 11.2 seconds.